Once the name server learns a mapping or a record, it caches that mapping. For example, TLD servers are typically cached in local name servers so that root name servers are not very frequently visited. The cache entries time out after their time to live or TTL. Cached entries may be out of date. If a name host changes IP address, this may not be known all over the internet until all of the TTLs for the cached records expire. The dynamic updates for domain name system are provided in RFC 2136. Now, let's take a look at DNS resource records. DNS has a very simple record format with 4 main fields: name, value, type, and time to live. Type could have different values. For example, it is A for hostname to IP address translation record, NS for name service type of records, CNAME for canonical to alias name translation, and MX for mail server records. If we have a type A record, the name is the host name and value is the IP address of the host name. If we have a type NS record, the name is the domain and the value is the host name of authoritative name server for this domain. If we have a type CNAME, the name is the alias and the value is the canonical name. And if we have a type MX record, the name is a host name and value is the name of mail server associated with that name. Resource records are exchanged among hosts through DNS messages. DNS messages have 2 types, query and reply messages. Both of these messages follow the same message format. The first 12 bytes of message is the header section. There are a number of control flags in the header, the most important of which is the query reply flag that indicates if a message is a query message or if it is a reply to a query. The question section of the message contains the queries that is being made. The answer section contains the resource records in the answer to the original queries. The authority section contains records of other authoritative servers. The additional section contains some other records that might also be helpful. One thing that I did not mention by far is how a new record gets disseminated in the DNS distributed database. When you want to have a host name for your server, for example, networkutopia.com, you need to register it at a DNS registrar. You can find a list of registrars at internet.net. A DNS registrar is a commercial entity that ensures the requested domain name is unique. Then enters the corresponding record into the DNS system. You need to provide the host names and IP addresses of a primary and a secondary authoritative DNS servers to the DNS registrar. You also need to insert type A and MX records for your host name and mail server at the authoritative name servers. For each of those authoritative servers, the DNS registrar will insert a type NS and a type A record into TLD servers. We conclude our DNS discussions with briefly pointing out that DNS, like many other internet applications, was not initially designed with security considerations. DNS name resolution is an important first step towards contacting servers you want to communicate with. This makes DNS a critical internet service, which is also vulnerable to many security attacks. Denial of service attacks against DNS servers are among the threats. Such attacks have not been very successful against root servers. That is due to traffic filtering at the root servers and local DNSs caching TLD servers that still keep the service up with local servers still be able to contact TLD servers. Targeting TLD servers might be more effective for DDoS attacks, since TLD servers perform less packet filtering. However, caching at the local DNS servers still help mitigate the effects of the attack. DNS amplification is also a DDoS attack that leverages DNS resolvers to overwhelm a victim. This could be run with sending queries with a spoofed source address, which is the IP of the targeted victim. If the response sizes are large, this could overwhelm the victim, which could be real receiver of the responses. Redirect or hijacking attacks, which are carried with intercepting communication and sending falsified responses that affect connecting actual servers, could also be carried on DNS servers. DNSSEC, which is discussed in RFC 4033, is used to alleviate some of these problems.